Now, the movement of the wave would be less important if we were just recording outside, but most people record in some type of room. So, learning about acoustics is one of the biggest things when we deal with the fundamentals of sound, because we have to deal with how that sound bounces off of a wall. There's mainly two things that can happen when sound moves. Sound can reflect, which means that it bounces off of whatever surface that it's on, or it can be absorbed by that surface. Hard surfaces tend to reflect, and soft surfaces tend to absorb. So when we're dealing with a studio situation, we need to know exactly how those frequencies are bouncing off of walls, because those frequencies bounce off the wall and they come back and affect our listening. Unfortunately, most people record in a bedroom, which probably is the worst place for you to record. Why is that? Because you're dealing with parallel walls. Most professional studios are built so that they don't have parallel walls. Well, what do I mean by that? Walls that are perfectly parallel tend to give you what we call standing waves. That is that a sound can bounce off of one wall and bounce off of another wall and hit each other and cancel each other out. That's in a worst case scenario. But most of the time in real world situations, it's doing something to the sound that will give you something other than a perfectly flat frequency response. What do we mean by frequency response? Well, that's the way that the room or piece of equipment that you're using affects the sound. You will either get peaks or troughs inside of the sound that weren't already there before you were recording in this particular room. The more dead you make the space, the more control that you have over the actual recording of the sound. You're allowing less of the room to be affected onto the sound. You also may be in a position where you want the room to be recorded on the sound. A lot of times we see this as real world examples when we record choirs in particular churches, because those rooms were built for the acoustics of a choir. So we want to gather all that information together at the same time that we're recording this choir. We also want the room. Knowing your room and knowing your space is the reason why you pick a particular recording space. Most of the time, places with high ceilings, wide open rooms are going to give you great reverb times. A lot of other spaces that are more closed in will give you the ability to have a tight, more controlled sound. So what is reverb? Reverb is actually a time. It's the time that it takes for the sound to leave wherever it's going, hit something, and return back to you. It is actually the time that allows our senses to know how big the space is that we're in. The bigger the room, the longer it's going to take for that sound to go somewhere, bounce, and come back. That will give us the determination of why we say, okay, I need a 1 second reverb, a 2 second reverb, or a 3 second reverb. The longer the time, in essence, is saying that we're in a bigger room. Another important concept when we're talking about waves and the way that sound moves is phase. This is probably one of the most underestimated or misunderstood concepts in basic audio recording. First of all, phase is a relationship. You can't have phase with just one waveform. Phase is the relationship between two waveforms. Depending on where these waveforms are in their travel and how they add together can determine the strength of that waveform. Adding waves together is just like adding numbers. It's cumulative. Depending on whether the wave is going up or the wave is going down can affect the sound. If I have two waves where they're perfectly the same wave, and one is going up and one is going down, at the same exact time, they can cancel each other out. This is called being 180 degrees out of phase. What does this mean? This means that in certain situations where you have more than one microphone, your signal can sound weaker if you're not properly in phase. This is something that needs to be checked by all engineers when you're recording with more than one microphone. Phase is extremely important. Also, another concept that I want you to fully understand is the decibel. When we talk about the decibel, this is how we measure the loudness of a sound. But a lot of people, again, mistake this number to think that it's a finite number, when in actuality, it again is expressing a ratio. It's the ratio between the threshold of hearing and the sound pressure level of that given moment. So that's very important to understand when you're getting these concepts. The actual number of the decibel is not a finite number. It's a ratio between the threshold of hearing and your sound pressure level.